Share screen. I need to share my entire screen. Perfect. Okay. So howdy everyone. So tonight we're going to talk about web dev fundamentals. This is a absolutely wild style of presentation. I haven't exactly tried something like this. Long story short, what we're going to do is we're going to review a couple of concepts, but most of the time is going to be spent going through a demo where we build a very simple website out of HTML, CSS, and JavaScript. No frameworks, no fanciness, no nothing, just HTML, CSS, and JavaScript. I've gone through most of the process of building this and scaffolding a chunk of it out. And I've pulled out, hopefully enough so that I can remember kind of where I went with things. And I will also be pointing out a number of the problems and issues that I ran into along the way. So some of the things I'm going to show they might work, but they're not good practice. And other things might not work for reasons that will not become apparent until about 20 or 30 minutes later when something else causes the thing we did earlier to break. So it'll be an interesting style of things. There we go. So yeah, let's jump into it. There we go. So web dev fundamentals. So we're going to start by talking about in chunks. One is just some of the technologies, right? HTML, CSS, JavaScript, key browser primitives that we work with. And then we'll also talk a little bit about different frameworks that are used for web development and why those are valuable. Then there's a principles piece, right? What do we care about when we're designing websites? What things are we looking to evaluate? I went up instead of down. The key idea that we're going to talk about is static sites versus more web apps. This is not a clear-cut distinction by any means. We'll talk about it later, but the goal is to kind of help separate ideas of, hey, when might we want to prefer more, basic technology? When is it worth kind of investing in a larger scale framework, larger scale project, and when do we need that? We'll also talk about some of the key factors involved with that for helping evaluate those trade-offs. And then finally, we have our demo, which will be HTML, CSS, and JavaScript. Nothing else. There was an idea to try to say this, but I think this will probably cut it for time. But if you want to take a look at it in the end, we can do some stuff there too. Okay, technology. From languages that shouldn't exist, JavaScript, to frameworks that shouldn't exist, JavaScript. No, React, but many others too. So our browser primitives are HTML, CSS, JavaScript. How many people have written something using this? Right, I'm talking about a framework, but I'm talking about an actual HTML, CSS file, JavaScript file. Okay, 50% or so. All right, that's not bad. How many people have actually done manual CSS styling? Okay, how many people enjoy doing manual CSS styling? Okay, that's what I thought. So, browsers use three main languages for defining websites. So HTML, as mentioned, is pretty much the easiest of them. It is hypertext markup language, stands for. I will not even begin to enter the debate about whether it's actually a programming language or not. I'll leave that for people to Google. But the goal of HTML is to control the layout and the structure of a website. So your website has a bunch of different, for lack of a better term, components that are part of it. It's structured and broken down into different parts of divs and texts and forms and whatever else gets thrown in there. And somehow all of this kind of nested structure turns its way into a website. And the goal of HTML is to define effectively a hierarchical structure of how these components are nested and related to each other that can then be used both for navigation dynamically, if you need to do dynamic behavior with JavaScript, or alternatively for figuring out the styling for things through CSS. Speaking of CSS, I point here, modern HTML stuff. So HTML5 had a new thing called semantic HTML. We'll talk a little bit about this, but the idea is that we don't want to be using div for everything anymore. We want to use meaningful components. There's a number of reasons why for this. One is for screen readers. The other is just for our own sanity. Alternatively, things like SEO. So Google will go in and say like, oh, here's an article on the site. I can pull out a chunk of that article if people are searching for it. So there's a lot of reasons to do that. Now, speaking of CSS. So CSS is cascading style sheets. This is effectively the style of the layout. So you have a hierarchical structure, that build layout, and then how that actually gets displayed on the website is pretty much controlled through CSS. Additionally, every browser has kind of a default style sheet that gives it, your lists have bullet points, you have a little bit of spacing around titles, that type of thing. Navigating around that one and trying to undo stuff that the browser automatically does is also one of the many fun parts of CSS. Modern CSS has a mix of things. So there is CSS3, which is a modern thing. That is much less modern. I think they've done away with CSS versions as well. But, you have a thing called Sass and CSS. And these are basically additional languages on top of CSS that try to do a bunch of things better. Some of them are just, basically CSS with many more features and options. You can do things like variables and other stuff like that. So utilities there. And then another idea is styling libraries, such as Tailwind. If you haven't heard of Tailwind, it's basically anything that you pull in. Bootstrap is another similar type of thing. One that I use a lot is called Bulma as well. And the idea is that you don't really have to write as much CSS, but the classes for basic CSS actions that you want are all available. And then most of the time, they also provide a number of higher level components. Cards, if you've seen them, the card thing is a very common abstraction for displaying things such as tweets or whatever else. What do we call them now? X's? I don't know. Anyways. And then you have JavaScript. So JavaScript is your dynamic and interactive behavior, right? This is the big granddaddy of web hell, per se. This is the language that was built in basically a week and somehow became the most prolific thing used throughout the entire world. Don't know how that one happened, but it happened, so we have to deal with it. So modern JavaScript is very different than the original, JavaScript language. We'll get into some of the things like prototypical inheritance or many of the other pieces. But ever since ES6, which is about 6 years old now, I think, JavaScript has a lot of the standard kind of class structures of things. It has cool things like Lambda expressions. It has many nice features that actually make it a relatively convenient language to work with. One of the things that JavaScript does not have, though, is types. That's another topic, but many people appreciate the value of types, particularly when you're working in larger teams. The more people that you have on a project, the more those people need to be able to coordinate at different points throughout whatever they're developing and share information about the structure and data that is going on through the system. And types is one of the easiest way to do that, in part because it's validated by the compiler. If you do something wrong with the type, then the compiler will yell at you until you go and fix it. I have also fixed a large number of things where people have added TypeScript and have effectively completely abused it to get rid of all the type safety. And it took me well over a week to unroll a chunk of that for a very small project. We're talking like a 2-3 page web app. And it took a week to go through all that. And then very lastly here, I have a small note about WebAssembly. WebAssembly is effectively its own little program that can, it's like JavaScript, but much better. It's a much lower level language. If you're familiar with Java, Java has Java bytecode that runs on a Java virtual machine. It's a very similar type of idea. You can take whatever language that you want and compile it down to WebAssembly, and then your browser can actually run WebAssembly instead of JavaScript. And so this opens up the possibility to just get rid of JavaScript and write whatever stuff that you want to run in the browser in another language. Java, perhaps, maybe not the best one, but other more modern, fun languages like Rust, perhaps, or whatever new language happens to be your cup of tea. And so finally here, that regardless of whatever language or framework tool is used, these are effectively the fundamental technologies powering the browser. If you write React code, that React code is somehow turning into HTML, CSS, and JavaScript. And it's a very complex process of how that exactly happens. But the idea is effectively the same. It goes down to those browser primitives and then runs. Of course, WebAssembly throws a small wrench in that, but very few things are using that at this point in time. So all of your React code turns into HTML, CSS, and JavaScript. You need to know how those types of fundamentals work, particularly when debugging code. Because what you see in the browser is not going to be React or whatever other web framework that you're using, front end or back end. It's going to be the HTML, CSS, and JavaScript that's sent to the client. So you might be trying to debug styling issues and you're looking at raw CSS, or you're looking at raw HTML, trying to figure out why the structure of something is off. So those are the kind of things that we need to be comfortable working with, regardless of what technologies you'll be using. Speaking of technology you'll be using, frameworks. So frameworks are effectively a structured library for building applications. This is a very rough definition. There's no clear one, but the general idea is that your framework imposes some type of structure on how you approach the development process. So effectively, kind of force you into a good path, or at least a stable path, or a well-known path. As long as you stay on that path and people kind of agree on what that path is, then it's much easier to kind of coordinate and communicate. If you're familiar with design patterns, it's a very similar type of thing. If you recognize the design pattern, you know the kind of general idea and approach that's going on. And it's the same type of thing with a framework. Framework is kind of out there to say, this is how you break up things into components. This is how you approach certain problems of, say, sharing states. This is how you approach the problem of how to organize your API. All of those types of things are stuff that frameworks generally present some information on. So front-end frameworks, things for rendering in general, Angular, React, and Vue are the big three ones. There's many others like Svelte and a variety of other weird things like Astro and whatever else happens to be popping up. There's basically a new one every week and plenty more every day that you just don't hear of. Some of the things important here are simplicity, developer ease of use. How easy is it for the developer to do things, particularly when compared to JavaScript, so on. Reusability is another very key component. The more that you have larger websites or more complex styles or whatever else going on, the more you're going to want to reuse that throughout your project. A very simple example is some type of header or navigation bar. Almost every page is going to have the same key structure. It might look slightly different depending on where you are, but it'll pretty much be shared. And what you don't want to do is have to manually copy and paste that to every HTML file that your system is serving back, right? Every HTML file having that entire chunk, well, one, that's a lot to try to manage. But then the second you have to change something in the header, now you have to go through every single file and try to change it there. So the reusability is important there. And then finally, you have reactivity. This is kind of the thing that React introduced and became famous for. Without too much detail, the general idea of reactivity is that when something that the user does causes a change to the application, that change gets automatically reflected in whatever is displayed back to the user. So in other words, the user clicks a button to increment the count, and React does all of the reactive magic to figure out where that count is used and how it needs to update whatever text or something more complex that's displaying the value of that count. It's a very crude thing. If you haven't seen React before, that's a little hard to grasp, but yeah. And then lastly here, you have a thing called static site generation. So this is a complex thing, really, but the general idea is very simple. If you use any type of framework, at the end of the day, it goes down to HTML, CSS, and JavaScript in one way or another. Static site generation is basically, well, instead of serving the client this massive framework that they have to deal with, if the content stays the same or is similar enough, then we can just say we're going to compile, whatever that is, and turn it into the HTML, CSS, and JavaScript that we would send to every single person, but do it once at the start and then send that out to everyone. You can think of it as like a manual form of caching, right? So instead of having to run whatever work it needs for React to render, the page for every client that happens to visit the site, you do it once, and then that client just gets the same, HTML file that happens to be spit out at the other end. So it's basically compilation. That's really what's going on here. On backend framework side, some things here. This isn't too much of the focus, but mention it. Things like Next, Rails, and Go. Most of these control a good chunk of the backend stuff. They also do a lot of the same type of imposed constraints for things. And many of them also have some degree of rendering support for being able to render things on the backend server and then send that as an HTML document back to the client. One of the key things here is that these things are generally full stack solutions, right? They do that backend as well. And then you have this idea of convention over configuration, right? You may also see this as like an opinionated framework. So I believe Next uses that in their marketing. And the general idea is, the point here at the top, which is that you want to try to impose structure as a framework, particularly in an environment like web development, where there are so many different possibilities. So that as well. And then last idea here is called server-side rendering. This is its own mess, but basically it's kind of like static site generation, just you have more dynamic things. So you do what you can on the server side and you handle a whole bunch of other dynamic things. So it's basically static site generation, just you're generating a different site every client call. So it's the equivalent of rendering things on the server. So two ends of the same coin, but one is when you have very, constant content, and the other one is when you have very dynamic content. Frameworks have trade-offs. Apparently, it just goes off the end of the sentence. I think the idea here, in general, is that while there may be many benefits to a particular framework or things that you can get out of it, the frameworks have trade-offs too. There is a complexity increase from adapting a framework, right? That's something you have to consider. And then you also have the different, whatever project that you're working on, or people involved that play a role in that too. For instance, I'm quite comfortable with React because I've worked with it a lot. I've also used Vue a bit. I have never touched Angular. Right. So even if Angular is, let's say, conceptually more simple than React or Vue is, my level of familiarity with it is going to make it much easier for me to jump into a project that's using technology I already know. So if you have a team that already has 4 or 5 different Next.js web apps, right? Next.js may not be a very simple piece on its own, but you already have that complexity for other things. So if you just have one small site, hey, make it a Next app, right? We have a team that knows the technology, they know how to manage things, they know how to maintain it. We have probably a good chunk of custom code for that. We know how to deploy it too. And if we run into any issues with it, then it probably applies to the rest of the stuff we're working with too, and we want to know about it. So that's a case where, hey, we're taking a much larger chunk of complexity for this project, but that's okay because the complexity as a whole is much better because we only have one piece of technology we're working with. So food for thought. Okay, principles. Yeah, these are a whole bunch of weird terminology you hear thrown around all the time. So we'll talk about static sites versus web apps. So the content is static in a static site. The site shows the same content to users. It's kind of what I was talking about earlier with static site generation or whatever else you're getting back. Every user gets the same HTML file, page looks exactly the same. So this is, HTML, CSS, JS assets. You might also have images or whatever else type of things, but there's generally no type of backend server for state. There's asterisks there. URLs are hard-coded, so whatever pages exist on the app are whatever's there. You're not going to have any type of, say, like LinkedIn / someone's username and be able to dynamically go find the user that is, because every page is going to be effectively pre-compiled. And so it's just going to say, oh, username.html, does that file exist? Yes or no, and send it to you if it does. If it doesn't, then you'll get a 404 or whatever. And pages can always be cached. Always probably needs a little bit of an asterisk here, but it is very close to always, right? Because effectively the page is just sending the same content back to every single person. So as long as the content's not changing, which it might once you update things, and there's your bit of an asterisk. But in general, for the same build of the website, the content is going to be the same for everyone, and that can be shared. So the client handles rendering and any dynamic behavior. This could be, whatever amount. You could even have things where it just sends a giant chunk of React and lets the client kind of figure it out, which is the original of React, but less common nowadays. And then you have JavaScript available for any dynamic behavior that you do need. So things like forms or submitting things or whatever else. And there's a good chunk of things you can do without having to get, a crazy backend. And you can also have little mini backends where it's like a MongoDB or just something else that you're just kind of communicating with back and forth. So yeah, can make fetch calls for data. So things like that, exactly that type of database thing. Okay, web apps. In a web app, your content is going to be significantly more dynamic. The site is going to show custom content to users for one reason or another. Usually there's some type of backend server involved, usually being pretty much almost always. There's going to be some type of server state that you're going to have to keep track of. And then some web framework that's kind of processing and handling that, things like routing or whatever else. URLs can be dynamic, right? So as mentioned, you can just access pages and it will generate whatever it needs at the given time, whether it existed before or not, doesn't matter. So you can effectively have infinitely many URLs, so which can be convenient for things. And pages often can't be cached. Often is much, less than always. There are definitely many situations. And you can also do things like breaking pages up to do other, very odd things with it. But there are different possibilities there. And then finally, the server is often involved in rendering for performance. This is your static site rendering or static site rendering, server-side rendering, and static site. They're all the same. We have too many SS algorithms, SSD, SSR, SSE. And this allows faster access to data, right? There's no round trips going back and forth between things. And so here's kind of your idea, right? Dynamic behavior, interactivity, complexity. Complexity is not even spelled right. The more you go from there, the more you're starting to get closer to a web app as opposed to a static site. But of course, this isn't a clear, linear scale, nor is this even, exhaustive, right? Just something to help conceptualize things. All right, let's play a particular game. Static or web app. So for let's just do the first one, right? Should this be a static site or should it be a web app? So personal portfolio website. Static, probably, right? When might you want to do a web app out of it?
If you got like a lot of stuff that you're uploading at once, you could like have like push it on like a backend server, just have like retrieve whatever stuff you get like at load time. Yeah, that's still be static. I think.
That's still probably static, I'd say. Right. So what if you had something where you're showing off something you built that's part of a web app or part of a web app system? So you're basically embedding a miniature web app into your website as kind of part of a portfolio. So that might be one reason. You could also do other crazy things. If you were like, I don't know, selling books and wanted to have, account system or whatever else. But for the most part, static site. So password manager dashboard. Web app? Probably a web app. So you might be able to do static site. So if it's something like where all the information is stored on the client side, so then you have a static site that handles the whole dashboard stuff, send a bunch of JavaScript to do some degree of interactivity, but the core data and customization can pretty much all come from whatever's stored on the client. So do some stuff. Business site that has some online orders. Web app, possibly. So probably depends on the business. So there are online orders where you don't even need to make an account, right? You just go payment form, select this payment form, and you're done, right? No need for, you're going to need a backend server to process that, but you don't need a backend server for the web app per se, right? Or for whatever the website is. Get by. Customer support forums.
Static. Yeah.
Could be a mix, right? If you have account stuff, pretty much always going to lean more on the web app side because you have to handle that. But there are, of course, other things you can use for authentication too. So Auth0 being, various things. Business site with online orders. We did that. Oh, I'm going up instead of down. Restaurant site with rewards program. Probably closer to a web app because account stuff for rewards program. But a good chunk of it could probably be static as well, right? How often does the website change their menu or their location or whatever else? That also gets into, hey, caching. So what's the difference? So yeah, SSD's website. Static. Yeah. I've been trying to think of a use case to make it dynamic, but I can't. So if anyone has one. Okay, so some key factors, and then we'll dive into demo stuff. So engineering depends on managing trade-offs, depending on whatever situation is. And so this has factors. This is by no means exhaustive. Is it all of them? It's a couple that I thought were particularly prevalent in web development. Maybe not even the most prevalent, but unique towards web development compared to some other types. So what is development velocity? This is most important when a project is volatile. Websites and web apps in particular. Yeah. I have a chat. Oh. Chat. Angular is crazy, crazy. Yeah, I agree. I think there was the comment too. I have never used Angular. I was supposed to use Angular for a class, but many people complained, and so said, okay, well, I'm not dealing with that anymore. So, see, development velocity. So yeah, so as a project is changing, right? So if you're working at a company and you're like trying some new type of product, you might change the UI a bunch. You might decide, I want to have this here, this there, or totally get rid of that section, or wait, no, add it back in. Whatever else might be happening. And so the more that things are changing, the more important that you're able to basically develop things and react quickly to that. No pun intended. Woo. Oh, I clicked off to Zoom. Application size. Larger applications will require stronger internet access, right? This is a huge thing. So for instance, I think it was Uber did a very large rewrite of their app a couple of years ago because they started reaching the limit of what iOS allowed to be downloaded from the App Store when on mobile data and not Wi-Fi. And so Uber, particularly for transportation, people want to download the transportation app when they tend to be not at Wi-Fi places, when they tend to be out and about rather than at their home. And so this was a key concern for them. So they looked into trying to reduce the application size so that, well, one, people are able to download it and hopefully get more customers that way. But also to be able to better when things are on, bad internet because someone's, out in the countryside or whatever else might be going on. So obviously, the larger the company is, the more you're dealing with scale, the more those types of concerns start taking effect. Similarly, performance, page load speeds can be critical. Amazon, for instance, did a lot of research back on how important page speeds are, and they found, is it like every 100 milliseconds, like millions of dollars or something absurd like that. So a lot of money can be involved in that. You want page that goes faster, and as before, you need fewer resources, particularly on your backend, because the faster that your backend's running, the faster your page is doing, whatever rendering it needs, then the fewer things that you need to have doing that at the same time. Responsiveness. Responsiveness in general, better visibility and interactivity for users. When they interact with something, they instantly or close to it see the effect of whatever it is that they did and how that changed. It helps for learning applications, also helps for avoiding frustration of endless loading bars and whatever else. Very similar to kind of performance as well, same type of thing. Responsiveness is basically the performance side of things when the user does stuff. Same thing. Accessibility. Accessibility is important. It increases the potential audience for things, particularly when you look at people like the elderly, number of whom have things like eyesight problems or motion problems where like many touch applications, right? So if they're on apps or trying to touch things, that can be difficult to do those controls because they've kind of lost some of the motor skills as a result of getting older. There's also legal concerns around accessibility, so things like that. So noting, and then remember these depend on both the project and the people, right? So same thing. So it'll be up to whatever's going on in order to evaluate, which of these trade-offs are the most important. Can we throw away performance for this project and just get a working prototype and then maybe go back and do it? Or more likely than not, never go back and do it anyways because that never happens. But yeah. Okay, let's get into demo stuff. A little bit later than I liked, but that's okay. Woo. All right. So I am going to try to lean this up just like this. Nope. Nope. All right, we're balancing it on this. There we go. Okay, am I audible in the back? I'll try to talk a bit loud too, because it's tricky. I need both hands to type. So yeah. Okay, so we're gonna build a little website. What this website does is it provides a list of Pokemon and allows you to search them. That is all. But it's gonna be the best search that you've ever seen, I swear. I don't swear, I take that back. So what we're gonna do is we're gonna go through things kind of step by step and kind of run through everything. So first is this basic, effectively, it's an HTML like preamble. right? This is kind of the standard structure of a website that you will see when you write something out of HTML. So you'll see this doctape HTML. This indicates that it is HTML. Then you'll have this HTML tag, a language, and then you get into this head section. This head section has a bunch of different metadata and other things about the document that is important for the browser to know in order to parse the file correctly or start structuring things, or it can begin processing the HTML that you've actually sent. So for example, the char set, how the file is encoded, different encodings could result in different things. One thing you might notice is that I have the little accent E from Pokemon. You could do other things like I think perfect. Nice. Okay. So you can do this, and this looks pretty much exactly the same, right? But you could also just have, the accent E in there because it supports UTF-8 encodings. Then you have this meta name viewport thing. This is basically telling the browser effectively how it should try to lay out the website in terms of dimensions. And so basically the width should be the width of the device. This is not the default because many different mobile devices try to effectively trick the website to render it larger and then rescale it so it fits on a mobile device. It's dumb, but that's what happened because most websites were not built to work on mobile devices that were 368 pixels. Initial scale 1 is the default for everything. However, this often gets included because iOS 9 back many years ago had a bug, and so people started adding this onto things. I learned that in preparation for this presentation. And then you have title, description, basic information about the website. And then down here, you have some related things. So one is a style sheet. This is your CSS file. So that CSS file has all the styles. And then down here, you have this index.js file. And then you can put, whatever type of JavaScript stuff you want in there, right? So you would have a JS file and a CSS file, which has some spoilers in it. However, we're not going to use these files. The main reason being is keeping them all kind of together in the same place where it's just this one file is much easier for us to see for purposes of the demo rather than switching back and forth between a bunch of files. In general, it's good to have separate files for things for a multitude of reasons. Caching, separation of concerns, yada, 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 particularly if your styles are shared throughout the application. But we're just going to throw them down here. This is not exactly standard, but it is possible and works on the majority of browsers. So we're just going to do it because we don't need to be that concerned about, total browser support for everything. Yeah.
Is there a preferred place to put the style instead of tags?
They should go in head. Yeah.
Both of them.
Yeah, script is slightly different because it basically interrupts the process to run the script, but most scripts should go in head.
Okay, I've seen some cases where it's like at the bottom of the body.
You can. I have this one here too. You can keep them outside here. Where is our closing HTML tag? I guess it's there now. So you can do a bunch of things like that, but for the most part, a huge variety of things works. I like this because it's nice and simple. It's also kind of similar to Vue. Yeah. Okay, so let's go ahead and start building some structure of our website. So we're going to build some semantic HTML stuff. So what we're going to do here is just kind of outline some structure. So we'll start with the simplest thing, which is going to be just a title. And so we will call this focus search. I'll copy the fancy E here so I have it. And then we can do a little bit of description. And I'll just copy this here and throw that down. Right, so let's open this up, browser. There we go. We have a website. We've done HTML. We're 1/3 of the way there. Okay, premature because things are about to get much worse. So we can do other things, right? So HTML is a number of possibilities. So you can do things like, say, bold, right? You don't necessarily need to use CSS. And the main reason is that this is about being semantic, right? If the style was just to be bolder, then that's, not really anything meaningful. But if in the HTML we say that this part of the text is important, then that can be conveyed to things like screen readers or whatever else might be going on. So you can have something like that. And now we clarify that it's about Pokemon in case that was not clear. Whoa, why can't I close that? What the heck? Okay. So moving back here, more semantic HTML stuff. We want to talk about different sections. So there are a variety of new tags that allow you to basically group things. These are the main additions of the semantic HTML part of HTML5. And so we can put this chunk in a section to basically say this is the title section. There's no particular rhyme or reason for how you group things. Do what kind of feels helpful, particularly for people navigating either via screen readers or Google kind of trying to crawl your site and find things. Other ones are things like you have article. So article like that. And then you can do some other stuff as well. So what we're going to do is we're going to build a little mini search form, and then we're going to throw a table in that. Semantic HTML actually has a thing, which is search. So this is experimental. I think it's still in the process of being added, but major browsers support it. So I will use it here. And we can throw in a form, and that form is going to have two things. It's going to have an input that is of type text. Is there a search type? Huh. We'll stick with type text because I have no idea what type search does. And then we'll have a button, which will be type submit. And we'll just say go. Okay, so now if we open this up, we have a search box. We have a button. Looking good. Okay, so you'll notice IntelliJ is kind of warning me about stuff. It wants to have a label here. This is because anytime that you have input, it's unclear exactly what that input is for in many cases. So it's good to associate a label with whatever you have. So in this case, I'll do a label search. So, and we'll see that reflected here just like that. You can also have labels that are effectively hidden. There are other different tricks and stuff that you can do with it. There are also ARIA labels. ARIA is particularly for accessibility. However, there's a saying that no ARIA is better than bad ARIA. So I will not begin to open up that can of worms because I'm not that good at it myself. But it's something to keep an eye on if you do end up in a professional type of web dev project. Okay, back to code. So now we have our little form, and we can build a table. So the way a table works is that you have two pieces. You have a table head, or it's just a T head. So, and that will have a table row. And then in here, you will have table headers for all the different columns of your table. So we're going to have the ID. So this is whatever, the Pokedex number is of our little Pokemon, in case you forgot we were doing Pokemon here, because I am not creative. We're going to have the name of the Pokemon, and then we will also have the type of the Pokemon. So this should give us something. Yep, doesn't look that fancy. That's okay, but it is indeed a table. And then we will have our table body. This follows the same thing, except instead of table header, we do TD for table data. And then we just throw whatever we want in here. So for instance, I'll keep things simple. What ID is Pikachu? 24? 24. Someone's going to check me on that. I'm going to get it wrong. Pikachu. And then we will throw in one last table data. TD. And this will be for, 24 to the type is electric. Yep. And so there we have our table. Yep. Very good. Okay, so we have a table outline, not much there, but we at least have some structure for it. And so now, we have our table, we have our search, and there's one last thing we can do, which is we can add a header and a footer. Right. So let's start with a header. So we will add a quick header with a navigation element, nav being another one of our semantic HTML pieces. And we can throw in a list of list items and we'll links. And so this will be basically our home page. I'll write that here. It goes inside of the A. So this is UL is unordered list, LI is list item, and then A is basically anchor, which is a link. And so our href is just going to be to this page, index.html. We can add another one. We won't have any other pages, just us. But we could say we could have something like an about.html. And then we could have an about. This. So now that we have all of this, we should have a little list, right? We click on home, brings us home. We click on about, and it gives us a 404 because we don't have an about page. Okay, the very last thing we'll do with HTML is we're going to add a footer. So down here at the bottom, we will add our footer. And our footer is going to consist of one little message, built with love. And I'll use our emoji stuff so we can get a little heart in there. And then, because it can, copyright, and I'll find our copyright symbol. That 2023. Right. Just like that. See, every good homemade personal project has to have built with love somewhere on it. That's pretty much how it works. Right? Just them's the rules. Okay. So we have some core type of HTML structure. However, it looks like absolute garbage because we're missing a good chunk of CSS. So one thing, for instance, our heart should be nicely colored. There are a variety of different ways to do styling. I will do most of them in this style tag, which is the same way that you would do it in a separate file, just located here. But there is another way called inline styles. So I can do something like a span. A span is basically just a wrapper around something, very simple wrapper. Span and div are similar but different. I will leave it to people to have fun Googling and cry. So our span style is going to be color red, right? This is text, so it should turn our heart a red color. And now we have a red heart. There we go. Step 1 of CSS. It only goes downhill from here. Okay, so the first thing we're going to do is we're going to set up our website so it's not all kind of lopsided all over the place. So we're going to do this by taking the body and giving it some additional parameters to basically condense the website down, structure some of the text, make it look a little bit better. And the main things we need for this are we are going to give it a max width. We can do something like, say, 800 pixels. And so our website like this now has a max width of 800 pixels. CSS is lovely, isn't it? We'll jump back to that in a quick second. Now, if we go down here, we'll add a margin. Whoa. Margin 0 auto. This means that it will basically center itself onto the page, right? So our website has a size of 800, so it's effectively centering itself there. And then we'll also add, okay, let me open up this so we can actually see what we're looking at here, because this layout probably looks a bit confusing. This is the body, right? This is what the body looks like. Basically this, well, I'll just select it here, right? This is what the body looks like, right? It is centered and it has 800 pixels in the middle, but all of our stuff is shoved over to the left. So it looks awkward. So what we'll do is we're just going to center this. I do not need to access that. And we're going to do text align center. Okay, perfect. All of our text is aligned in the center. You know, it's not text. These random bullet points up here, because the list is the entire width of the page. And the table, because I don't know, table is table and table follows weird rules. So we'll get to that. We'll start with our navigation. So first thing we're going to do is we're going to take our navigation list. So in CSS, you can do selectors for things. I haven't talked that much really about this. But body is basically our body element. We have a selector that says whatever the body tag up here is going to have the following styles. And then these are basically just an arcane set of properties and different that you have to memorize. That is unfortunately the reality of it. Most of the time we just Google it, right? That's how I got through this. I just Googled a bunch of things. So by no means you have to try to, learn every single bit of nuance, but you figure out and you'll kind of pick it up as you go along better with it. So in nav URL, we want to give a padding of 0 because lists have default padding according to the browser style sheet. So you have fun with that. And then our nav list item, we're going to change the display from being a block, which means it basically takes up an entire horizontal chunk of the website and goes from top to bottom, to be inline. And inline means that it basically takes whatever the content is, sorts that out, and then puts whatever just immediately following the content. So if you have a bunch of inline things, they all end up next to each other. A list would be something that has a bunch of inline things. Yeah. And so now we get these aside. We can also have some fun with styling from things that are not exactly styling. For instance, we can add some little borders just around our links, make it look slightly more menu-y. And this gets it a little bit closer to something that you might, reasonably see on a low quality website. So perfect. So we're hitting the vibe just perfect. Okay, so lastly, we kind of have our table to tackle just a little bit. And so our table, we need to give it a specific width. We are going to give it a width of 100%. This tells it to fill all available space of its parent. The parent here is basically the body or content of that, which is wrapped in a search or whatever it is. And so it'll take up all that possible space. We're going to give it a margin top, just to give it a little bit of spacing of 16. So we have that. We can take a quick look at what this looks like. Oops, now. Right, so this all spreads out, right? So this is taking up the full width. The browser basically automatically tries to break up the columns into relatively organized groups. It looks terrible. So there are plenty of things you can do to kind of give things specific column links and whatever, but we are not going to do any of that. We're just going to let the browser do what the browser do. Except for a few things, which is that we don't really have any border around our table. We have things just kind of free floating. So we can do table header, table data, because all of these different cells you want to give a border around. And we are going to give it a border, not a border width, but it's just a border that is 1 pixel and solid. And so we should have a border around our table, which we do. It looks great. However, you'll notice that there's multiple lines, and there is a fun thing for that as well, which is border collapse, which is collapse. And now it turns into one line. A bunch of these properties are magic. Some of them do very basic things. Others do ridiculously complex things. It's just very weird like that. Now, the last thing that we can do, we probably need a couple more Pokemon. Don't know any others, so I'm just going to copy a bunch of Pikachus. We'll just have a small armada of Pikachus. So now we should have this. They're all the same. And what we're going to do is we're going to give it just a little bit of styling, where it'll be a table body. So this is the body of the table, right? Not the header, but we want the body. And then we're going to do something fun in CSS that is called nth child. Or is it colon? Or I need the table row first, then colon, nth like that, nth child. And what do we want? Is it odd, even? Even. And so this is basically saying for every even row in our table, we're going to do this styling. And what we're going to do is give it a background color of some type of, maybe not light slate, but just normal light gray. Right? There we go. So this looks right. What happens if we do odd? It flips. And that's what we want, right? Now, one thing that's interesting is, wait a second, how is this odd? Well, you might say, well, okay, so the first row is the header, that's index 0, and the second one is index 1, right? So it's an odd index. That's not accurate because we are in the table body, right? The table header is contained elsewhere. Nth child is 1 indexed. I don't know who came up with that one or what languages they've been programming in, but it is indeed 1 index. What did they say, MATLAB? Yeah. So yeah, so you get a bunch of different things there. And then we're going to do one other thing with our footer. And so we're going to do our footer position fixed. So this is going to basically snap it to a particular place. We are going to put it from the bottom, 0, effectively 0 pixels, so all the way at the bottom. And then we're going to do some magic, right? So if we look at this now, we have our footer down here, right? It is at the bottom, but it's shoved over to the left. So what we can do is we can say, we are going to move it left 50%, right? Well, now the start of this is centered. Huh. Well, the way we get it centered completely is we can do a transform. And our transform is going to say that we translate along the x direction horizontally by negative 50%. Now, this 50% is effectively the container that this whole thing is in, right? Which is the entire website. It's the full width, basically. This transform, or this translate x 50%, is 50% of the content width, not the container width. So the end result is it shifts it back to the left a chunk and we get it centered. Right? Pure wizardry, really. Okay. All right. We're going to do, let's get to scripting, right? We'll end our CSS adventure there. Okay. So we have a script. We can write JavaScript here. JavaScript is, of course, our programming language. It's a bunch of things. Modern JavaScript is ES6. It has what's called modules. It's basically a standardization of how you can import and access things. If you've ever used require, you've probably seen some mess of that type of stuff. So there's things like that, and it tries to do away with that in favor of a more standard approach. You can have scripts that are modules and scripts that are not modules. Scripts that are not modules will modify global scope. So if I do something like this, and I just have a function here, right? This function test ends up in global scope. If I do a module, type module, then this is no longer in global scope. So it's good to use module scripts when you can. It's even better to use actual modules that are JS files, but for sake of demo, I'm doing it like this. That way we can see everything and very quickly kind of scroll up and see what we're looking at. I'll minimize the style here so we can see all of our stuff. And I'll minimize, well, we're doing stuff with the table, so I'll keep it. Okay, so first, we need to get access to JSON data. I have this file, Pokemon.json. It contains a whole bunch of Pokemon and their ID names and types. Simple enough. And what we're going to do is we're going to try to pull this into our website. Now, we can do this in a very messy way. So we do import JSON from /Pokemon.json. Okay, so let's see what happens. If I go over here to console, you will notice it's giving me problem. It does not like trying to load this because basically it is a JSON file and it's expecting to be importing JavaScript files. Now, this gets into a mess of kind of why this is dangerous, but the short thing is if you import a JSON file and you think it's JSON, it basically evaluates that entire thing in order to parse the JSON. However, if you get sent a JSON file that is not actually JSON, but something else, like JavaScript, then you're evaluating a bunch of JavaScript code where you may not have been expecting to, and that can cause problems for security, for receive, whatever else. So you want to avoid any type of malicious input. And so there's a fancy syntax, which is assert type : JSON. This is actually new, right? Oh, it just doesn't like it use. This is actually new. You'll notice that if I do this in Firefox, it says import assertions are not currently supported. Firefox is one of the main browsers that is yet to implement this. But if I were to pull it up in Edge, which is Chromium, you'll notice that this actually will work. Well, that's a different, it's trying to load an icon. I don't have an icon. Let's do this, alert JSON. Let's do it like this. It is, of course, an object because it parses the value. So we'll do a JSON.stringify. Right? There's our whole JSON data. Looks good? Okay. Now, because this doesn't work on Firefox, we can look at other opportunities. So the easiest opportunity is just to say, JSON is JavaScript. That's the entire point of JSON. It's JavaScript object notation. So if we have a JSON file like this, we can just turn it into a JavaScript file and just send back the entire chunk of a JSON object as JavaScript instead of JSON, right? This isn't always possible, but it's possible in this case, and it's a convenient solution and kind of worth calling attention to. So because we have modules and stuff, we can just do export default, and it'll take this entire object, which is JSON, and pretty much send that back as the result. And so now we should be able to import this just fine. It comes in as JSON, or it comes in as an object. We do the JSON stringify of it. Edge is happy, and more importantly, Firefox is happy. Right? So fun mess of things. Okay, so from here, we want to start rendering things. Now, here kind of a sequence of, here's a bunch of different attempts for things and different methods. I'll skip over one of the messier ones and just focus on two. But one is basically using the raw JavaScript DOM. And so we can do this with a function render table. I will call this down here. So we can just call these types of functions because we're in the scope, and it'll just run the function. And that render table is basically going to say, we need the table body, right? And so we are going to create a body, which is going to be equal to, well, let's take a step back and think about this for a sec. So we have a table. We want to be able to dynamically populate these rows. So what we're going to do is we're going to take this table body, and we are going to iterate over our JSON and build one of these table row entries for everything in that JSON. We're going to take all of those, turn those into effectively HTML DOM objects. DOM is the document object model. And then we're going to add that into the body and then set that on the table. That idea make sense? Okay. So our body is going to be a document create element, tbody. We are going to iterate for Pokemon of JSON.Pokemon. Whoa, sorry about that. So we're going to iterate over JSON.Pokemon. And for each, what we're going to do is we're going to build a row, right? So our table row is going to be const row is the same type of document.create element, which is row. And then row.innerHTML. So there are a variety of ways to do this. You could keep going on through basically the entire DOM structure and building the nodes one by one and attaching them. You can also use innerHTML as a little bit of a hack for that. The performance isn't matters, so feel free to for it. And basically, we're going to set this to a string of the HTML we want. And HTML what we want is basically the table row, which contains 3 table datas, right? One for each column. And so the first table data is going to be the Pokemon ID. Whoops. The second one is going to be the name of the Pokemon. And then the third one is going to be the type. Now, type is an array. We could do some magic to kind of print it out in a pretty format, but just being an array to a string will give it, a comma separator, which is good enough. But you could do more fancy things if you wanted to, and transform the data however you see fit. And then the very last thing we're going to do is we're going to do the body, and we are going to append child, the row that we created. Right? So we build the row, we add it to the table body, and then we can do that a bunch of times. And then the very last thing we need to do is add it to the table. So we could do this in a couple of ways. Just document dot get element by ID. Table is the easiest way. We'll need to add this. And then we're going to append another child of the body we made. So this document.getElement by ID allows you to basically find different nodes in your HTML structure by an ID, basically an ID attribute. And so we're going to add that here. The ID is table. It's probably better to use semantic names for things. So you might say like, Pokemon or Pokemon table or whatever else. But I'm just going to use table because it's simple. And so now if we refresh, we get our alert to the JSON data, and we get, what in the heck is this? Okay, something weird's happening. Let's take a look.
Maybe it's like two,
I have this hard coded and we don't really want this hard coded. Yeah. I just want an empty one. And then body child row. Good. Take a look. Oh, it's alerting. Whoops. Oh.
Make the table body as a child, so you're adding on to what was already there.
It is. Does anyone see what's wrong here?
Oh,
Row is not an HTML tag.
oh, yeah.
It's TR. There we go. Yep. There's all our data. Okay. So there is another way to actually do this, which is templates. I'm going to skip over some of the messy stuff and kind of jump towards the end of it, just for sake of time. And we can use a template to basically define the structure of what it should be. And we store this in the HTML. So we can do a template here. I will set an ID of template. And then we'll take this template and we will be able to throw in our structure. So we have our table row and then table headers, this. Now what we can do is we can use a thing called slot. If you've seen slot in React, it is basically the same type of thing. It is something where a parameter being passed in can go. And so slot name is ID. Right, slot. And then we will do this for name and type. Okay, so we have all of these things, ID, name, and type. These are all in our table rows. These are within a template. And so what we can do is instead of creating basically an element, we are going to get the template and we are going to effectively copy it. Is the way you would use standards for that. And so the way that we can do this is document dot get element by ID template dot what is it, content dot clone node true. This is basically saying clone everything, and this is our row. And now what we can do is we can run a query selector all over all of our slots. And for each slot, what we're going to do is we are going to basically say that we are going to replace the slot with whatever new value that we want to put in that. Our slot names happen to match the property of our JSON. That's intentional. And so what we can do is we can say parent node dot replace child. So this is saying replace a child of whatever. So this is the replacement. So replacement and then current node. So this is how you replace one node with another, right? It's a little bit of a loop around because it needs to build the correct document view, but this you would do it. And our replacement is going to be a new text node. This is just for raw text, that's all. And the data is going to be whatever our Pokemon is at the field of the slot name, like this. Right, and then once we're through all that, we should just be able to append it, and we should get the same thing. Aha, we have duck stuff. Did I do? I probably did table header instead of table data. There we go, no longer bold. You'll notice that the footer is now blocking the content. Lovely. That would be a CSS thing to go in and fix. I have the solution for it, but for sake of time, I'll go through. The very last thing that I want to jump to is to be able to do a search. And so we can do a search in a couple different ways. But the easiest way for sake of demo is to basically do a form submit. So we wrap this in a form in part due to semantic HTML, but also because we have a button submit that will effectively submit this form. And that form will have access to things like our different data here. And so we'll be able to take whatever the input text is and get easy access to that. And the way we do that is we'll have our form. We will want to have an on submit, and we are going to call on search So, is it? So is it on search event? That's it. You'll notice event is deprecated. There are a bunch of better ways to be able to do event handlers for reasons I won't get into, but this is simple and works for our needs. Instead of adding it into this module, we actually want to create a global function because we need it to be accessible from that form handler. And so we can just create another script tag, just like this. And so this script tag will be able to define our function on search in a way that's accessible. So this script is normal, it's on search works, and that goes into the global scope, right? That basically goes onto the window object. Our module script is not, right? This render table function won't be accessible. And so our on search function is going to take that event, and it's going to do a couple of things. First off, we haven't this much, but you'll notice when I click this, it basically reloads the page, right? Can we see that? It does the page reload. That's the default behavior for a form submit. It'll basically send some type of web request with a bunch of information about whatever you entered into the form, and that's what it does by default. Most of the time, we don't want that. And so we're going to do event.prevent default. Frameworks will generally do this automatically. We are not using a framework. We are using JavaScript, so we do it manually. Now, our search is going to be whatever that field was that is up here. And so the way we can access this input text is we can give it a name, and our name will be search. And so event.target will give us our form object. Then we can access search, which is that basically it's the input, and then the value of that input is the string that was entered into the search field. And then search equals. And so now what we have to do is we have to iterate over for const Pokemon of JSON.Pokemon. Oh, can we do it here? No, because JSON's coming from a module. So we will throw these together. And instead of defining it like this, we will have to define it as window.onSearch. So we're going to modify the window object to attach things here. And it'll be this function, just like this. And so now we have access to our JSON.Pokemon. We will do the same type of thing where we're going to get the row. There's a number of ways we could rebuild the entire structure, but we have the structure. And so the trick that we're going to use is we're going to effectively hide the element. So if a row shows up in the search, it'll be visible. If a row is not in the search, will not be visible. Yeah, question?
Yeah, when you put that on search event handler in the HTML, and you said before that event was deprecated, are you referring to the fact that like the better way to do it is just to like grab the element on an event listener?
Yes, add event listener is the best way to do that. So yeah, document.get. So our table is going to be constant. So what I think we can do is we can do const table equals document get element table. T-body is fine because that only happens once. But we will do our template as well, just to avoid doing a bunch of lookups by ID and loops. It's a very minor thing, but can be helpful. So, and then we will do table append child. So even though we're, in messy JavaScript land, we can still have some small semblance of things. And so search, so we're going to get children. So what is the index of the child for a Pokemon of, ID 1? Well, it's index 0, right? So because it's the very 0th element in that body. So we're going to do Pokemon.id -1. And what we're going to do is we're going to change the style. So display can be used to basically, we saw it earlier where display inline versus display block in order to kind of rearrange our lists, but we can also do it to hide things. And so what we're going to do is we're going to check if the Pokemon.name to lowercase, because we want to do a case insensitive comparison of our search. Includes search to lowercase, and we can take this search to lowercase and move it out here. That way we're not doing it within our loop. That includes search So if we were smart, then we could go through our JSON and basically change it so that the names were lowercase. But that has its own messes too, because we probably want them to be capitalized in the output display to users. And what we're going to do is we're going to set display to empty, effectively not in default value, or none if it's not present. Okay, let's give this a go. So we have this. We can search. You can see I have a few things. Search for Charmander. Here we go. Charmander, Charmeleon, Charizard, Chimchar, Charjabug. Look good? There we go. Okay, not as many chaos problems as expected. So things are time. But you might notice if you're looking at the results, something weird has happened with some more of our styling. Right? Remember that whole nth child thing that we did to do basically odds, so or evens or whatever it was, but the ID being odd here, right? So the odd IDs are still showing up as gray. It hasn't figured out that the others are hidden. And that's because nth child doesn't work off that. Effectively, it's still there, right? It's still present in the actual browser DOM. It's just not being displayed on the screen right now. And so you would actually have to go back and kind of tear apart a chunk of things. You could also restructure it so you could use nth child in order to do this, but just remove the content from the DOM entirely. There's a bunch of different options. You could also throw in classes for things and do even more dynamic behavior, but it very quickly turns into a mess. So point here being, it is good to kind of be aware of the HTML, CSS, JS stuff, but it is a mess. Messing around with static site generation is definitely a good thing. Maybe at some point in the time we can talk about that, but you can do a lot of stuff with it. So I want to jump very back real quick to our slides. So why are we talking about this? Devs wanted. So our SSC website needs a little bit of TLC. I think I can pull it up here. Maybe I shouldn't, but I will. ufssd.org. I can spell it correctly. So here, you'll notice that among other things, it says fall 2021. There's also a bunch of other stuff here. There's some of the things that are missing. There's stuff, details about the organization, links to any of the recordings or videos or other stuff done, as well as things about officers or whatever else. So I've been asked to kind of take charge of leading a bit of an initiative to try to get this website updated, probably some type of static site. And what was suggested to me as a potential idea is to find a couple people who are interested in basically, mid-level dedication, not looking for anything crazy, but something more than, once or twice on things. And I will work with you all to basically kind of build through the website as kind of like effectively like an engineering manager or project manager or whatever else. And I do not touch a single line of code, but I help you and help you through whatever it is with things. I don't know how well that's going to work, but it was recommended to give it a try. So if people are interested on that, feel free to come and talk to me, message on Discord, so myself, one of the other officers or whatever else. And let's try to get our website into shape. So, all right, thanks all. Apologies for going a couple minutes over here, but we'll let you get it going. So thanks all. All right, stop share screen.